Okay, so let us start. And last class, we started to discuss stack data structure, okay. And if you recall, a stack can be used to store a collection of items. And in what? In a feature, we call it LIFO. So last in, first out feature, is it? So kind of, you can think of it like a container, and you can only access at the top. Okay, because last in, first out is first in will be at the bottom, is it? And the last in will be at the top. So that's why last in will be the first out. And you can add at the top. So add a new item at the top. We call that operation push. Is it? You can also remove top item, and we call that pop operation. Okay, and you can get to the top item. That's, we call it top. Okay, so, and the last class we also discussed implementation using array. And when we implement using array, we have two instance variables, that the top index and the array itself. Okay. So this is a general idea about stack. Okay. And so today, let's take a look more about how we use stack. Okay. So stack applications. So stack can be used in a lot of places. Okay, so like reverse something, because it's last in, first out, is it? So reverse something. And stack also used quite a lot for backtracking. Backtracking, is it? So kind of like if you have a maze, then you have a maze, something, and you go to somewhere, is it, and then go somewhere, and then maybe here is dead end, there is no outgoing approach, then you need to get back, is it? But so all of those turning points along your route, then you can use a stack. Is it like turn 1, turn 2? Is it? So turn I. So you can use the stack to keep track of the turn. Is it? So the top one is your current one. Is it? And if it's not working, then you get the back to the previous one, and then try different route. Then you will have different turn. Is it? Different turn. Okay, so that's can be used for backtracking. And in operating system, we also used stack concept. And one of the thing we already mentioned quite a lot, if you recall, we previously said stack memory, heap memory. That so later on we will also discuss like the concept of runtime stack. Okay. So anyway, so there are a lot of applications. So today, what we will see, the first one is to do conversion, okay? So we can convert decimal number to binary format. Okay, so binary is only 0, 1. And the decimal, we already know 0, 1, 2, 9. Is it? And those are the single digits. And then you can have multiple digits. So, but how do we convert decimal number to all just 0, 1? Is it? So 0, 1. So matching, is it? And if you have 2, then it's 1, 0. Is it? If you have 3, that's 1, 1. If you have 4, that's 1, 0, 0. Is it? So this is decimal format. This is binary format. So how are we going to convert? Is it 5? Then it's 1, 0, 1. Is it? So how are we going to confirm this? So let's see. Let's take a look at example, like suppose 13. We want to find its binary number. So here the algorithm that we can do it, we will use a stack. Use a stack. Okay. So we first do like 13. We can module 2. Then it is 1. Now for this one, we push it to stack. Okay. Then we do 13 integer division. Okay, what we get? We get 6. Okay, with this 6, then we do module again. So it's 0. Is it? And for this 0, I push it to the stack. Okay, and then 6 integer division 2. What we get? We get 3. Is it? And then what next is we can do module again. So 3 module 2, what we get? We get 1. And for this one, we can push it to the stack. Okay, then 3 module 2, what do we get? We get 1. Okay, or 3 integer division 2. And then with this 1, then we do module 2, what we get? We get 1. And 1 divided by 2, what we get? We get 0. Is it? So this one, we also need to push it to the stack. And because when we do integer division by 2, we already got 0. So we are going to stop. So the algorithm for the module part completes. Is it? So this is our stack. So with this stack, then we pop all of the number out. So we have 1, then we pop the next one out, then we pop 0 out, then we pop 1 out. So this 1, 1, 0, 1, then is 13th binary number. So this is decimal number, and this is binary number. Okay, so this is the algorithm. How can we convert a number to a binary number? Okay, so you just, whenever you do the module, then you push the result to the stack. And then you keep doing the integer division by 2. Okay. So here you see we can use a stack. Okay. So next, let's see, how do we code it? And over here for our method, the convert to base 2, it's not just base 2, okay? We can also support other base. So you can specify base. Generally speaking, you can have base 2, base 8, is a base 16 something, is that? So different base, okay. So here is a number. So what over here we first need is a stack. So you need to create a stack first. And it's an empty one. Well, in this case, is it? Then we can start to do the module and the integer division by 2, okay? When the result is not 0, that we can keep doing. So that's why here we have this loop. That generally speaking, with a lot of stack application, we do this kind of like while loop, because you don't know the definite number of the iterations, okay? So you use this while loop and then you first push the result, the module result to the stack. Then you update that number, divide by the base. For our discussion is 2. So this part is you fill the stack. Okay, you fill the stack. And then what next one you try to do is, so once we fill out, if you recall, we need to get the number out. So while the stack is not empty, that's also a lot of time when we use the stack. When we do stack application, we do the first part is try to fill the stack. And the second part is enter the stack. Then you can get your result. Is it or some other condition? Or other condition. So a lot of time we use a while loop. Okay, so over here is we need to collect all of the digits in the stack. And then in the stack, and if you recall last class of stack implementation, because for the top we can throw exception. So that's why over here we put it in the try-catch block. Okay, so if the top number is that it is 9 greater than 9, because that's based on our base, the base 2 or base 8 or maybe base 16 something, So if it's some other base, so then the number in the stack can be greater than 9. So then in this case, we need to do the conversion. Okay, so like for base 16 is a hexadecimal number. That's used a lot, like for network address, MAC address. Okay, they use base 16, etc. So then in that case, what you can do is, then you need to check, because after 9, there is no digit you can describe. So we use letters. Okay, so using letter. Because for hexadecimal, it's 0, 1, 2, all the way to 9. Then it's A, B, C, D, E, and F. Those is so this basically represent 10. This is 11, 12, 13, 14, 15. So that's how you describe base 16. Okay. Otherwise, you just output that digit from the stack. That's the corresponding base number formatting. Okay, and when it's all not empty, you can keep doing this. So we can see this algorithm basically is not too complicated. What next is, so we have some numbers. So first is 1001. We convert to base 2, and then base 8. Okay, and then base 10 decimal and the base 16 hexadecimal. Okay, so we can run this program and take a look at the result. And if you take a look, the binary as it's changed to all just 1 and 0. This is 1001. Okay. So 1001 for its binary, it's much longer. That octal, then it's 1751. And the decimal, it's 1001. For hexadecimal, it's 3E9. Is it? Yeah. So that's how we use stack to do the number base conversion. Okay. And what the next one try to show us is a search method for a stack. So suppose instead you want to search a certain item in the stack. How are we going to do that? Okay. And in this case, because if you search, you don't want to disturb the original stack. Is it? So we don't want to change the plug-in stack. We want this and change it and modify. Is it? So the way to do it, if you recall, in our previous class, we discussed the clone method. That's a deep copy one. Is it? So then we can just work on that deep copy one. And generally speaking, with the stack operation, because the stack is already filled, is it? So we can use the while loop, is it, with a certain condition. Here is you want to check until not empty. But once you find, so you get to the top item. Once you find it, then you can jump out of the function, is it? Otherwise, within the loop, you keep do the pop. Is it? You keep do the pop. Okay. So this is pretty straightforward. Okay. And when you reach the end of the stack, when the stack is already empty, you still cannot find the item, definitely you need to return false. Okay. And then in this program, we also then initiate another integer stack. Okay. And we add some numbers. So from 0 to 9, we add 10 numbers, is it? Then we try to search if number 8 is added, is it? Is there? And then let's see, we said 8 is there, so it's true. Okay. Okay, so that's regarding this example. It's pretty straightforward. And then what next to try, let's see. For the next one, the first part is just what we already discussed, search item, is it? So this part we already discussed, okay, search some item. And what is the next one? Try to show us, yeah, let's take a look. So we are going to do some string reversing. And string reversing, it's not mandatory you got to use stack. Okay, you can have some other way to do the reversing. Okay, here we just try to show you can use a stack to do reversing. So what over here we try to do is first we do some string cleaning work. Okay, and this method is return a string and it take in a string. And we are going to use a string builder. And why we use string builder previously we explained. Okay, because the string itself is immutable. Is immutable, and each time when you add, it won't add on the original, it's create a new string. Okay, but anyway, here we use a string builder. So we are going to loop the string letter by letter, is a one by one. And then we are going to check if the letter in the string is a letter or if it is a digit. Only if it is these two cases, we will keep that. Otherwise, we are not going to keep some special sign, okay, of the string. Then we just call string builders append method, is it? And we also convert the letter to lowercase, and then we return this new cleaned string, okay? And so that is not a big deal. And then let's take a look how we reverse string. So this is the in order string. And this is reverse order, the return one. Reverse order, okay. So what over here is, and we use the library. Later on, I will explain, okay, stack. And that stack is a generic stack. So that's why over here, our stack is going to be character stack, okay? So it's a character stack, and you got to use this wrapped one. So it's a character stack. It's going to store single letter, okay? So it's a letter. And this, if you recall previous, we also learned array list. Whenever you want to use array list, you also need to plug in something, is it? And for this angle brackets, for the generic, you cannot plug in primitive data type. You got to plug in reference type. So reference type, that's why, like for integer, then you need to use our wrapper integer. Is it? And for double, then you need to use the reference double. Okay. So this is the primitive. This is a primitive type. Is it? And you can also have the wrapper type character. Is it? And also Boolean. Is it? So anyway, you got to use the wrapper type. Okay, and then we are going to do the new stack. Okay, create a stack. And what over here, we create a string builder. Okay, string builder. And for this string builder, then the first thing we needed to do is we get the string. Okay, and for each of the letter, we are going to add it to the character stack. Okay, so you have like A, and then B, C, D, and E. Is it drop into the stack? Is it? And what next one, we are going to loop through the stack. We get each letter out, so E out, and append it to a string, is it? And then D, and then C, and then B, and then A. Then we get all of them out and append them. So this is the string builder. And with the string builder, then you convert it to string, you return it. Okay, so then we get a reversed string. So this is reversed string. Okay. Okay, so that's regarding the string. So what over here we try to do is, here you have some sentence, is it? And we clean the sentence, we will remove all the space and the special one. And then you're going to convert it to all lowercase. Is this, was it a cat saw? So that's your new string after you call the clean string, okay? And what over here, we want to check if the sentence is polyndrol. So polyndrol means the original order and the reverse one is exactly the same. That's called polyndrol, is it? So how do we check that? So this is a clean sentence, okay? Then for string, we have that equals method. And then here you have the reversed string, is it? This is already cleaned. So if the original order and the reverse one the same, then this should be true. If it is true, then it is polyndrol. That's it. Okay, so that's this program. It's also pretty straightforward. And we can run this program. And then take a look. Yeah, so it says that is a polyndrol. Okay, it's clear, is it? Okay, then let's get back to this example again. So in this example, if you take a look over here for the stack, is it? We create an integer stack. And here, what we import is the Java's stack. Okay, so from Java, this is from the Java libraries stack. Okay, and so that because previously our two examples, just specific type can only support integer, is it? It cannot support a character, string, or other type. And here, if we use a library one, just like the array list, then it's more flexible, so you can plug in any reference type. Is it? So over here, the first what we did is an integer stack. So this is an integer stack. Okay, integers. And then over here, then over here, we have the character stack. So if you use the library provided stack, then in one program, you can have different type of stack that coexist in this application. Okay. So anyway, if you want to use the library one, just keep this in mind. You need to import this class, okay, stack class. So you need to import it. So you must need to have this import statement. Then you can go ahead to use it, okay. Okay, so this is the idea about library stack. And next, let's take a quick look of the library from Java official document, okay. So Java official document, the Oracle official document, so stack, we can see as it is a generic one. Later on, we will learn Java generics, okay, so don't worry about that. So it's a class, and it is from this java.utility package, so stack class, okay, stack class. And you can also see its hierarchy relationship, its object is the root class, super class, is it? So we already learned. And the vector, basically, it's a super class. Okay, later on we will learn those. Okay, so don't worry. And it also said to implement some interface like a clonable. Okay, we already learned. And then regarding this stack class, it's a super class, it's vector, is it? It's what? Its feature is LIFO, is it? Last in, first out. Okay, last in, first out. And it has 5 operations. Okay, So it's push pop, we already learned. And in Java stack, okay, the top, it doesn't call top, it's called pick. So pick basically is our top operation, okay. And it also has anti-operation, and it also has a search. And for the search, it's item search, how far it's from the top. So 1 away from top, 2 away, or 3 away, something like that, okay. So, and also it says in this case, then it contains it's an anti-stack, okay. And there is another data structure. You can also use it for stack operation. So it's called DAC. Okay, it's called DAC. And then if you want to use it, you can do array DAC. And the part, this DAC is double-ended queue. And later on, we will learn queue. So this is another data structure. So DAC is also a data structure. So it's double-ended. So that means you can access at both ends, not like a stack. Stack can only access at one end, okay. DAC, you can access at both ends. And the DAC itself, be careful, it's an interface, okay. And this is a class, concrete class. So, but you can assign the variable type as an interface, that's acceptable, okay. Because this array DAC implements this interface, okay. So then let's see, for the stack, so it only has this single constructor, create an empty one. It has a method called empty, and its top item is called pick, okay. So it's only retrieve the top item. It's not going to remove, okay. And the pop in stack library, the pop not just remove, it also returns the top item. Okay, so it return and remove. Okay, remove and return. So it has both functionality integrated in one operation for the library one, not like our one. Okay, the push just add an item at the top, and the search is to find. Okay, it says return number-based position, etc. Okay. So this is regarding the Java library one. Okay, and we can also take a quick look at that DAC. And be careful that DAC is an interface. If you want to use it, then you need to do array DAC. Okay, array DAC. So that's, you can do the DAC like an integer DAC, is it? But when you do new, you need to use that array DAC. Integer. Okay, so you need to do array DAC, the concrete class, for the stack case, okay. And for that array DAC, it has more operations. It says add first, remove first, and get first. It also has add last, remove last, and get last. Is it? So if we want to use its part for stack, then what we can do is add last. Is it? And what you can remove, you can also only remove last. because you can only access at back, is it at the last item, and you can also get last. So that's the stack related operations. Okay. You can also use, it has two sets of operations. So similar, it's offer last, poll last, pick last. Similar, okay. It's just one throw exception, the other returns null value, special value if there is no item to be available, okay. So that's regarding the DAC. Okay, so that's what we needed to know, okay, for the DAC operation. Okay, so I think today we just start.